Okay, so we're gonna go, it's 12:03, we'll go until 12:55. So can you do like a 1 minute intro and then I'll paste the questions?
Okay. Hey, my name is Michael. Right now, I'm prepping for a Google interview I have next week. It's for new grads for the first round, and yeah.
Okay, great. And then let me paste the first one. And if you've seen it, let me know and I can do something else.
Okay. All right. So we are given a binary array nums returning maximum length of contiguous subarray with an equal number of 0 and 1. These are the examples. Okay, so just to clarify the question, let's put some notes in docstring. So we are given an array of nums, and we have to find the longest subarray. So find longest subarray, and the subarray must include like zeros and ones only. Correct?
Yes, there are only zeros and ones, and that's it.
Zeros and ones. Okay. So give my binary array nums find two subarray with an equal number. Okay, so we're trying to find the equal number. Okay.
Mhm.
Find equal number. And there's only ones or zeros. Can this be empty? This array can be empty.
Yes.
Okay, can be empty. Okay, I'm gonna go like through some examples to try to see if we could like
Sure.
find a pattern or understand. So um, I do this longer one right here. Okay, so we start 0. The longest, so the longest array is length 6. Let's see. Okay, I'm just gonna use like left and right pointers to like um,
Yep.
see how long this array can be. Just to, like try to find something. Okay, so first one is okay. All right, so I'm trying to think right now of like how like so like I guess first things comes to first is like I would use like a sliding window because this is contiguous. Like it's subarray and usually use sliding window for a question like that. But I don't want to get straight into a sliding window because it might be like hiding something else. So I'm just trying to go through the example with like a sliding window and try to find some conditions as to when I would pass like the left or like when I move the left and the right pointer.
Hmm.
But I know that for sure that I'll like have to like somehow like keep track of number of zeros and ones in subarray.
Hmm.
Okay, so let's say I have like a 1 counter and a 0 counter. Ones equals okay. So let's say I initialize see. So I initialize my left pointer, my left pointer to index 0 and my right pointer to index 1. So far we have uh 1 0, and then we have 1 1, and then uh we have 2 ones, then we have 3 ones, and 4 ones, then we have 5 ones.
So you're writing the ones where the zero
Oh,
is.
I just realized that. Yeah,
Yeah.
sorry, it should be 5, and we have 1 0
Mhm.
here. Um, okay. Well, right now what I'm thinking is like I'm trying to think of what I would like what maybe sliding into might not be the best approach because I'm trying to think of like how I would like move this left point and like when I would update it to.
Mhm.
Okay, let's see. All right. Can I try like just like writing out like a brute force solution, and maybe I'll like get something from that. Like just like writing it out, or would you like me to
Sure.
still try to?
Well, you don't have to code it, but yeah, I mean, brute force is you could talk about how you would do it.
Okay. Yeah. Um. Okay. All right. Let's see. I'm trying to think. So let's say we're iterating through this list, and we start at index 0. Uh, we would check. Let's see. Uh, let's see. So, mm, I'm actually banking right now. Okay. See. Right. So wait, this is going to really find an answer. So we find an equal number. It's huh. Actually, don't know. Let me see. Um. Yeah. Can I feel like a minute just like to like think about it real quick?
Sure.
Yeah. Sorry. Okay. 0, 9. Let me see. Well, what other like? Huh. Maybe. Let's see. Starting connects. Hash map names and hash names contiguous sliding window. Um. Hmm. Okay. Even with like the brute force solution, I'm not like because like of course I can like start at 0 and then I could like I guess like go over like the rest, like check like go over the rest of the like of the list.
Hmm.
Um and I could like count each amount like of like ones and zeros. But like the but the thing is, oh, okay, the thing is like it's like when would I like stop counting?
So if you get rid of the sliding window idea, because yeah, like you don't really know when to stop
Yeah.
counting because you don't know what it looks like later on. So for
Hmm.
like a brute force, for example, like think about like an n squared, I guess, right? Like you could just start at like every index and then like uh go through and just check the counts, and if they're equal then you know the length, right? That would be like a brute
Yeah.
force.
Hmm.
But how can we does that make sense?
Yeah. So just let's say you're saying that like we start at index 0 and
Mm-hmm.
then we would go through the rest of the list
Mm-hmm.
and then count the oh okay. So we start at index 0, we go through the rest of the list and count the amount of zeros and ones. And if they're equal, we would update I guess our max length
Yeah.
of subarray.
And then because
And
it's
then
brute force, you can like start at the next index and do the same thing,
yeah,
and yeah.
okay.
So basically we're trying to find like um yeah. So by equal, you can almost think of it in terms of one of two, like the easiest way to think about it is like so you have a count of ones and you have a count of zeros. And
Yeah.
there's many ways they can be equal, right? So for example, this is equal to this, right? This
Hmm.
is equal to this, and so on. And there's like an infinite number. But
Yeah.
instead of
Okay.
storing the count, is there any other way we can store this information to make it not like, so 3 and 4 and 5 and whatever are all end up being the same thing? Like, how do we store that information? Like, yeah, does that make sense?
Wait, so just repeat this. It's like how do you store like but yeah, can you please repeat that last part? Said how do you store what
Yeah.
exactly?
So if I have like, this, like, we don't really care like if it's this case or this case or this case or whatever, right? There's like an infinite number. Um,
Yeah.
we just want to know if they're equal. So is there any other way we can store, instead of storing the counts, can we store it in a simpler way to know, like, are they equal?
Okay. Let's see.
And then we
Uh
can we can use that to check like when were they equal before, or like, whatever. Because we don't want to do a brute force. So yeah.
yeah. Okay. I'm trying to see. Maybe it's like a like let's see. So okay, so I just thought of something.
Hmm.
So we can like so we need an equal amount of like zeros and ones, and we don't like another way to store this, or I guess to see if there's an equal number of zeros or ones would be to
Hmm.
like so let's say there's so this is like the total length of this is six like this is six.
Hmm.
So there should be like I guess like six amount of like like ones. I'm trying to think of like a math way it could do like the total sum of that subway would be six, if that makes
So
sense.
basically, what I was saying is, like, instead of storing them in terms of like the counts, we can just store like a difference. So, like, 0 can be like -1 and 1 can be 1. And if we ever have a difference of 0, then like we know that they're equal. Um, and does that help us in any way to know, like what if we're not at a difference of 0, right? What if we're currently at a difference of like 5? Is there any way to know of like, okay, we're at this index. How do we know like what subarray we need to make it equal to 0 from where we're at? Like something like that. Does that make any sense?
Okay, so you said just to reiterate what you were saying, so you're saying like we would use a difference thing to count like zeros as like negative ones and like ones as like positive ones.
Yeah, because
And
that way
then
we know, like, we only care about the difference. We don't care about how many we actually have. Like, we can have 10
yeah.
and 10 or 20 and 20 or whatever, but that ends up being the same, like, thing. So,
Hmm.
yeah.
Okay, so if we're at a difference of five,
Yeah, like, let's say we're at some place with a difference of 5. We basically want to know, like, can we take this difference and something before and make it a difference of 0? Because that way we know that, like, if we have a difference of 0, then we, like, have a valid subarray. So is there anything we can do there?
so let's say we have like a difference of five. The only way to I guess to get a zero is if like so let's say zeros are positive ones and we have five ones. Don't the only way to get like a difference of zero is to have um like the rest of that list must be at least like length five. So we can like subtract what's it called? So we can get the difference from the zeros. So like let's say we have like a let's say we have like let me see. Oh, my mouse is okay. One, one, one. So far our difference is like three. Oh, actually, let me put one of the zeros. So let's see, zero, 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 zero. So far we have a difference of three. So if we have like, let's say we're at index two here, and if you have like a one and a one, um, it's not possible to have. Wait, it's not like possible to have an equal subarray of. Huh.
Yeah, so we can't really go in the future, but we can go in the past and we can store some data. So the difference of 5 I was talking about is like, let's say we have this, right? So this would be 5. Um, And then later on, we hit like this case, uh, 1 0 1 0 1 0. So here we have a difference of 5, right? And then here again we have a difference of 5. So
Hmm.
because between them there's a difference of 0, we know that like the subarray between them is valid. And we have that like we can store that information, right? Like we have a difference of 5, we have another difference of 5. That means we like to go from a 5 to a 5, you have to have a 0 difference. So then we know that like this, like does that make sense? Like from here to here basically is a valid subarray now because we ended up like adding and subtracting the same amount from one to the other. Or it would actually
Um,
be I think I screwed that up a little bit like this. So there we go.
Actually, no, I don't understand what you mean by that. So okay, I'm gonna try to walk through this, like what you said, and see if like I'm
Mm-hmm.
missing like gap, there's a gap in my understanding. So okay, so from wait, did you say that we would like so we can't get things in the future?
We can't get things in the
Okay,
future, but we can store
yeah,
things that we already had.
hats. Okay, so that means we start say from here. So we have this goes up to index. So let's say this is 5.
Mm-hmm.
Um, so we say that we say our total like something like it's like 5, and
Mm-hmm.
then we go to the end of this should
Yes, our sum would be like 1, 2, 3, 4, 5. Going back, like yeah, I think. Um, okay, let me get rid of these. So and then it would be like 6, 5, 6, 5, 6. Okay, so like if we have this kind of thing, then wherever the numbers are the same, in between those, you have to have a difference of 0. Because like, how do you go from a 5 to a 5? You have to add and subtract something that ends up being 0, right? So if you notice, like anywhere between numbers that are the same, we have a valid answer. Like between a 5 and a 5, like this is
uh-huh.
valid. Between a 6 and a 6, like this is valid. This is valid, and so on.
Okay, so okay. I think I'm just starting to understand it a little bit more. So just to make sure, this would be like a subarray of length 3,
Uh huh.
correct?
Yeah, but this wouldn't be valid. So basically, I'm saying is like we don't include where it's a 6, we include everything after it because like it's a 6 here. Now I
Okay,
want to go
so
from a 6 to a 6. So I don't include the first 6, like where it was the first 6, but I include everything else. And it's like to go from a 6 to a 6, I basically have to add and subtract an equal number of zeros. To go from a 5
mhm,
to a 5, I have to add and subtract an equal number of zeros, and so on. So I can just
okay,
say, like, hey, I have a number. Anytime I had this number before, the subarray after that from me has to be length 0, or, have the difference of 0. Does that make sense?
yeah, okay, okay, all right. So okay, so we're getting the count difference 5, 6, and then so I guess whenever we like see like a past like we can store like the differences that we have like going across the list, and like whenever we see like a list that we've a number that we have already seen later in that array, uh we get like the things in between that.
Yeah.
Okay,
Now there is
okay,
one more case. So we can see that number a bunch of times. So like in this example, you see there's like a bunch of 5s and 6s, and we
yeah,
want the longest one. So how would we want to store this stuff? Like, for example, if I'm at this 6, do I want to compare it to the 6 in the middle, the 6 in the left, like which one? And how would we store our information to ensure that You know, if we see a number 10 times, we get the biggest result.
Um, I was thinking maybe I'm not sure this would be like correct, but like maybe we'd use like a stack, like a stack that would like hold like I guess the current index that was I mean the current like difference, and then also like a let's say diff, and then like a index, and then like each time we find like I guess we'd also have to use like a maybe like a visited set as well. So like
So you're
um
saying, well, what's the point of the stack?
okay, so the stack is to like so if I'm going through the if actually yeah so I guess my first thought was that like if I'm going through the array and I find like another number,
Hmm.
uh I found like another number, I would keep on popping till I get to that next number again.
Well, the
And then I
problem
would
with that is like if you were popping, like let's say I have like 4, 5, 1, 2, 3, 4. If I pop all of these, like I might
mhm,
need that 1, 2, 3 later on because I might hit a 1, 2,
yeah.
3 in the future.
Okay, yeah.
So I don't think a stack makes sense, but basically what we need to do is like, if we have a 5 and we have a bunch of other stuff, and we have 5 and we have a bunch of that stuff. So like every 5 we hit, like let's say we hit this last one, which one would we want to match it with to get the longest like answer?
Um it would be it'd be this one.
So if we match it
So
with
that's like
this one, like
it's
our
like the
subarray
conti
is this length. If we match it with the second one, our subarray is this length. If we match it with the first one, our subarray is this length. Like
okay, yeah.
the
Okay, yeah,
subarray
I
length is
think
from like between the two numbers. So
so then we gotta like store like I guess like the first occurrence of that.
yeah, exactly. So we'd want
Okay.
to just store the first occurrence of a number because we always want to match our current number with the first occurrence because that automatically gives us the longest. And then if we
Yeah.
know that we didn't see it, then then we know there isn't a valid thing. Okay, so I think we have enough. I think we can start coding
Okay.
if everything's good to you. And by the way, before
Yeah,
we start
okay.
coding, so what would be like the time and space complexity of like this?
I'm thinking. So we are iterating through this list, and we are storing, and we're storing, okay, and we're storing like at max like n items, like if
Hmm.
they're all actually this is n, yeah, like so the space currency would be O of n, and then time would also be O of n because we're just iterating through this list once, and we're storing like the first occurrences of of like the differences.
Yep.
And like,
Okay.
yeah,
So let's start coding.
okay. So I need a way to store the amount, the first occurrences. So I'm saying for first, let's see, I'm gonna have uh like a set. Let me see. Trying to think. So I would have like a first scene. Uh, actually no.
And I'll
Okay, let
just
me think
give you
about this
this, I
before.
guess.
Okay. All right. Thank you.
Or we don't need this.
Okay. Let me like try to flesh out this before I start coding random stuff. So we need to keep so we need to keep track of our first occurrence and like what's our first occurrence of something. And if we see that, so okay, so I'm thinking we have like a set. We have like a visited set of like what we've already seen
Hmm.
of like what we've already seen, and then also let's see. So what we've already seen and wait, oh, I just forgot. What was it? What we already seen and oh my gosh, I'm blanking. And a and I guess like a and I guess like a hash map of like where that index was seen.
Yeah, so why do we need a visited set and the hash map? Like basically when we hit a number, we're
Oh,
just seeing
that's
like
true.
where did we
Yeah,
hit see the number.
yeah, yeah. You're right. Okay. Yeah. So we need a hash map of like our first occurrence of like whatever number and
Hmm.
then like if we see that number if we see that number again like in the hash map we check its O1 lookup and then we get that index and then we subtract that our current index with that index side that hash map um and we could like update our max each time we like do that check.
Okay.
Okay, so I'm gonna have like a like a max sub array. Right. So just, I'm gonna initialize it to um, uh, negative infinity, and also a scene map equal to um, scene map um, to the hash map. And then while I'm iterating through this excuse me, for a num and prime range of nums, then we would check if nums dot I is in max subarray f subarray dot len subarray dot len if oh sorry should be CMap if nums dot I is in CMap we do the calculation so our max subarray length equals max subarray length and then the calculation is the current index should be I minus max CMap of nums I of nums let me I. Okay, but also I noticed that this hash map is not even it's not even like there's nothing in this hash map yet. Um, and also I need to build the differences. Oh my goodness, I'm forgetting a lot of things. How would I build these differences? Right now I'm thinking if I should build this hash map, the CMap before I start iterating through. But no, that wouldn't make sense. I'm trying to see like how I'd build this hash map with the differences. Um, wait, let's see. I'm supposed to be subtracting. Oh my gosh, subtracting the index. Um, okay, yeah, I kind of lost myself, especially with the fact that like I have to build these differences, and right now I'm just subtracting like even if this was like full, like let me see.
Yeah, so we have
Um,
we don't have too much time, so without coding, you can just let me know like what you did wrong, and then we can move on to the next one. So what would you have to do? Can you just talk through it?
okay, so I guess right here, I would see. So if it is in the hash map, I would have to like get like the difference. But also I
Mm-hmm.
need to calculate that difference. But if it's not in the hash map, I would add that to the hash map and then the first occurrence
Mm-hmm.
of
And then
that and the
how would
index.
you maintain the difference?
Yeah, that's the part like I didn't fully flesh out yet. But I think I guess I can have like a like a count of like a difference, and then like after like each iteration, I can update that difference. Like maybe like like if it's a zero, I'll plus equal one. If it's one, I'll minus equal one, and then I could keep that like throughout the whole list. And then whenever I whenever I get to like so whenever I get to that first iteration, I would say that, yeah.
Okay. Yeah, I think that makes sense. So you basically maintain a difference, and then you just, if it's in your map, you just get the difference, and if it's not in your map, then you just add it to the map. Yeah, and then
Yeah.
you just return the biggest result. I think that's good. Okay, let's move on to the
Okay.
second question, just so we don't run out of time, because we're at 30 minutes and we have 50. So the second question is this.
Okay. Design a system that manages the reservation state of n seats that are numbered 1 through n. Implement the seat manager class, seat manager.
And I'll give you the starter code to speed it up as well.
All right. So given, guys. Okay. Just to make sure I understand what this question is saying.
Sure.
Let's go through 6 examples. Okay, so we're designing a class. So designing a class of n seats numbered from 1 to n, and we're designing 2 functions. The first function gets the smallest number of so the smallest open seat, and reserves it, and then returns the number of that seat, and then unreserved reserves the seat with it. Okay, and unreserves. Okay, so for unreserved, we're always given like that seat number to unreserved. So it's not like the smallest one, to make sure, right?
Yes, we're always given a seat.
Okay, so I'm just gonna write down some notes so I don't lose track of what's actually like happening.
Sure.
Um, so reserve, reserve, get the smallest number open seat and reserve it, and then on reserve, open that seat. Okay, let me make sure I didn't miss anything. See what to give a seat number. Okay, and then so like this is like the like did I miss anything from like
Uh,
what's like
through what?
so this is like the like main idea. We have a reserve, which is to get the smallest number of open seat and reserve it, and then
So
unreserved is
unreserved doesn't unreserve that seat. You're just given a seat. So I can reserve a bunch. I can reserve like, maybe I get like 1, 2, 3, 4, and then I go and unreserve 3. So I don't necessarily have to, like, I'm not always gonna like reserve and then unreserve the same one. So unreserved can unreserve any seat, and then reserved gets the
yes,
smallest. Yeah.
yeah. That's what sorry, that's bad. As in that, I meant like whatever n is, like
Mm-hmm.
open
Yes.
and seat. Yeah, not
Yes.
that seat. Okay, all right. Um, okay. So the main things that I have to keep track of is like I guess seats,
Mm-hmm.
storing seats, and then also this the smallest open seat, and then
Mm-hmm.
I think unreserved is just pretty like simple. I just go into whatever I'm storing that seat in, and like unreserve it. I guess also state of seats. Yeah.
Okay.
So these are key things I have to keep track of. And let me see, what's the best way to store the seats? Um, so if there's a list, there's a hash map. Of course hash map would like to be faster for overall lookup time. I'm trying to see what would be the benefits of that.
Hmm.
Using let's see like how I would actually use that hash map. What would the key pair value be? Um, so seat, so say seat. Um, seat number. Um, seat number. Okay, let's see. Okay, seat number. Okay. Uh, yeah. Can you give me like a second, just like try to flesh out this idea real quick?
Sure.
Um, okay. So like what I thought of, I guess right now for like reserve uh is that like um I need so to keep track. Okay, wait, let me talk about this in it first. So first, I was thinking about like using a using um a min heap for like using a min heap for this for like to get the smallest open seat. And I think we'd best have like a global min heap, and then re- whenever I call reserve, I'll do like I would check that like I wouldn't pop the top of the min heap yet. I would check the top of the min heap to see if it's online, and I can see if it's online by by storing it like maybe like a um like an indexed like state list. So like let's say like a list of states, uh say from like 1 to n. And then let's say if I were to so let's say if I were to check the top of that min heap, I would first check if that state is open, and if it's not open, I would pop it. But then I also have to keep track of like all the wait, give me a second. Okay.
So if you so you basically, I see what you're saying. So you said like you have all these like seats in a heap, and then if it's open, like if it's available, then you pop, right?
Yeah.
But um how can you ever have a situation where it's not available and it's in your heap? Because like you're popping when it is available, so how can it ever be
No.
unavailable and in the heap?
Okay, so I meant like more like I would like so first I would have first I would I would initialize like I would init like heap of all 1 through n,
Right.
and then like anytime I'm like I call reserve,
Mm-hmm.
um I'm looking like at the top of that heap, um and if it's like like the heap after my first reserve, the heap will only include like the top of the heap will always be a online heap, if that makes sense, because like
Yes.
I'm like so like I'm like only popping like what's offline from that heap.
Yeah, so basically like everything in the heap is always online. So why would you have this like you were saying I want to check if it's online or not? Like if it's offline, you pop it from the heap, right? So how would so why do you have the list of states for like if it's online and offline? Where like you should know that like everything in your heap is online because if it wasn't, it would have been popped. Does that make sense?
Yeah, so you're basically saying like I don't need okay, yeah. All right, so basically I don't need a list of states. But then also let me see for the unreserved, open and see. Okay. Like I guess why I thought about having like a list of states was for the unreserved because like can I assume that like that they could pass in a seat that is like not open and I can't reserve that seat? Or is the seat that they
Yeah,
pass
so
in
you can
always gonna be
assume for
open?
unreserved, it will always be valid to unreserved.
Okay, so and will always yeah, I should ask the question right earlier
Yeah.
and always be valid. Okay. So that means I do not need a list of states because I don't use that for like for the unreserved.
Uh
Um,
huh.
okay. What is unreserved return? Make sure it doesn't it's void. So unreserved is a seat with the given seat. Wait, can I also assume that um will the reserve like that's just small wait, no, never mind. Okay. Okay. Using heat. I just lost train of thought. Okay. So I would have let me go back. So I would have a min heap. First, I'll initialize all things in the min heap, and the min heap would only have things that are reserved. So whenever I reserve, I would just pop from the min heap. I think I'm scared that if I pop it, I need to use it again. I'm trying to see that I don't have to use it again for anything else.
Yeah, so we have about 7 minutes left, so I'm gonna let you start coding just so we can get something. Um,
Okay.
yeah.
Okay. Okay. Let me just move this. So initialize my main heap, which is a list. Um, and I would also need so let's see, okay. Self reserve. Let's be self. So use main heap. So you get the smallest number open C and reserve it. Okay, so um, I would smallest open seat is equal to let me see that pop well main heap uh, and reserve the smallest number of seat and reserve it. Um, reserve it, and this takes it away from okay. All right. So def dart. So this this gets the smallest open seat, and since the main heap is only full of things that are open, so first I would actually initialize that main heap as well. So say for in range one through n plus one. should say, you know, heap that pen. Or actually, no, I should do heap, heap pop, heap the heap pop. Oh, sorry, push. Jesus, push. I. Put some number to I, and then smallest gets this reserved, and it pops it out. So then this isn't so once that's popped, that means this has been reserved. And then to get to the unreserved seat, I'm getting a smallest open seat, smallest open end seat. Let's see. So n is always open. I'm reserving it. So if so many is always um, uh,
Yeah, so you're basically just trying to take your seat that's unavailable and make it available now, and all your available seats are in your min heap.
um yeah, my brain just okay. So for unreserved, I am trying to get so okay, what bro, why is my oh my goodness. Sorry, can you with that again?
Yeah, so all your available seats are in your min heap, right?
Yeah.
So for unreserved, you basically need to take your unavailable seat and you need to make it available.
Okay, I just added to the heap then. Oh my goodness, Michael. Okay, so then yeah, then I would just add that n heap inside. Uh I would add that heap. So I would just do heap self that. I'll do heap q that heap push. And then set them in heap. And this which one of these returns something. I think this also returns. It's reserved. Does it return? Yeah, it returns. Smallest one's return. Smallest open C. I feel like I'm missing something. It's supposed to be simple. Um, remember. Oops. He push. So then you see number. Okay. Yeah. I think this is it. Um, should I give you like the time complexities now, or am I
So
missing
let me
something?
actually ask you about one thing. I think this does work. So in your init, you added everything to the heap.
Yeah.
So what heap methods are you familiar with? So there's like a heap push, there's a heap pop, there's one more. Are you familiar with the third one?
No. What is the third one?
So have you heard of heapify?
Yeah. Yeah. I have.
So what's the pros and cons of doing this versus appending every number and then doing a heapify?
Wait. Can you please repeat that? You said
Yeah.
cons of what?
So on line 120, so basically if I had your thing versus this, uh, same thing, but it would just look like this. So I would just do like min heap append I, and then I do a heapify or heap q heapify. Uh, is there a difference?
Um, friends. Five. I mean, wait for it. What? Who's that pen at? So are you saying instead of me doing this, I'll just do like
Well, I'm
heapify?
saying, does it matter, like your approach or what I have? I'm not necessarily saying mine is better. I'm saying, is there a difference? Is one better? Yeah.
There's I don't know. No, there. I don't think there is a difference. At least what I've been doing, and if there is, I would like to. I would like to know. Probably,
Okay.
but I don't think there is a difference.
Okay. Cool. So we're at 50 minutes. So let's do a reflection. So how do you think you did?
I think I did horrible, and I feel like I don't know if it's like the nerves or something. Like I'm not like nervous per se, but like compared to like me, like I guess doing like a legal question,
Uh
and
huh.
I've done interviews like before too. Like I just felt like nothing was going in like in my mind. Like I
Okay.
guess for the first question, I didn't like know like how to solve it.
Uh
But for the
huh.
second one, like if I did this like like in like 2 hours, I could do it like by myself like pretty easily. And I don't know. I think like I wasn't able to like have like complete thoughts in my head. I feel like a lot of things were scattered and
Yep.
yeah, and that
Okay.
really like I was like all over the place.
Yeah,
I'd say.
so I will say, from my experience, doing questions on LeetCode versus having an interview for a company you really care about, it's gonna be vastly different, right? Like, you're generally just gonna do worse. Like, you're very
Yeah,
nervous. It's hard to like stay composed. So I will say, like, maybe not. During a mock versus a Google interview, like in the Google interview, you're probably more nervous than a mock. So if
yeah,
this is the way you were in the mock, I would probably just recommend doing more mocks until you're comfortable with the mocks. And then the interview you'll still be more nervous, but it won't be like as bad.
yeah,
So that was one, is like you were very like I could hear like you were like, oh man, this is like what the hell's going on, like you're very
yeah,
discouraged. And
yeah,
there are going to be interviews where like, there's like two situations, right? Everything goes perfectly and you're like, yeah, great, great. And then like you stumble a little bit and it's like, can you stay composed?
yeah,
And for what it's worth, like I've gotten offers where I stumbled a little bit, but because I was composed, that's like a thing I think people look for. Like, in software engineering, you're gonna run into like walls, and it's like, well, are you just gonna like quit, or are you gonna like figure it out?
yeah,
So I think that's like a good test. So I definitely would not, even if you are discouraged, try to show less of it. Don't do the like, oh my god, like what's going on,
yeah,
like
yeah,
that type
yeah,
of
yeah,
stuff.
yeah. You're right. Yeah,
Um, because people want to see that, like, if things aren't easy, like how do you respond? Okay.
yeah.
So
I just, I
look,
just.
all right, go
Oh,
ahead.
sorry. Continue.
Oh yeah, I was gonna say. So I'm gonna go through the actual feedback. So
Yeah.
yeah, I mean,
Okay.
you're kind of right. Like, how you did. So you asked for the first one. You asked the constraints, which is good. Second one, it's kind of dangerous to be like, oh, it's contiguous. I'll do sliding window. At least you did realize that it doesn't work, because you were like, how do I shrink it? I can't. Um,
Yeah.
so And I gave you a lot of hints for, like, I basically was like,
Yeah.
here's the solution, and you were still
Yeah.
kind of like struggling. So I would definitely work on. So I think there's like three parts to a problem, like going from the problem to a just like a plan of like no code at all, going from the
Hmm.
plan to a solidly coded solution, and then doing a dry run. And it seems
Yeah.
like to me you need to work the most on like going from the problem to the plan
To,
with like no code at all very quickly and correctly,
yeah.
um, because you struggled a lot here. And so it seems like, you said you did a lot of topics. Maybe you like brushed a lot of topics, but you don't have like in-depth knowledge on too many of them.
Hmm.
So honestly, you can even go from like, take a problem, write pseudocode, like here's what I think, feed it into GPT, see if you were right, and like time yourself. Like I
Yeah.
would, like, you don't even have to code at all. Like get to that. And then from there, then you can work on like, okay, now that I have that, can I code it well? Because a lot of people will have a plan. It's like, okay, this is good, this is correct, and then they code, and then their code's like a mess. Um,
Yeah.
but for you, that's the biggest thing. It's like, if you don't even get to the coding because you're taking, so long during your solutions and overcomplicating them a lot, then it doesn't really matter like what your code quality is, because it's like you basically never get there. It's kind of like, you might have like, you might be like the best interview taker in the world, but like you never get an interview. Like it doesn't really matter, you know.
Yeah.
So I think that's one of the things I'd work on. So yeah, basically I kind of guided you into, and even the brute force. Like I would have thought you would have figured out the brute force for sure. You just go through like every like two like nested subarray. You just keep track of ones and zeros whenever they're equal. Like take the longest. That one was like pretty straightforward. and you were still kind of like stuck. I don't know if you were just like discouraged, but you kind of had a lot of like brain freezes. But you did get the time complexity of like what I told you correct, but it was just like very slow, and obviously wouldn't have passed.
Yeah.
And then you talk through that you're writing. Like I feel like your communication was good. The biggest thing is yeah, like don't show discouragement.
Yeah.
Um, you yeah, and then when you were coding, I feel like you were just kind of lost. You were like, oh, I'm gonna use the number. Oh wait, it needs to be the difference, and it's like if your plan is very clear in your head, like honestly for this problem, if your plan is very clear in your head in Python, you can write a solution in like 5 minutes.
Yeah.
So you just need to do that part quicker. And then let's see. You I don't think you talked about edge cases too. Well, I think you did ask if it had only ones and zeros, and I did say yes. I think for an empty array and stuff, that would have been fine. So out of like all the grades, so basically problem solving, coding, DSA, and communication out of 5, I think I honestly gave your problem solving a 1 here because I gave you a ton of hints and you were still like unclear. And then your
Hmm.
coding, I gave you a low score, but it's one of those like because the first one was so bad and you just had so limited time for the second one, it's
Yeah.
like you couldn't have done well. And then as well for DSA, I gave you a low score because like so basically the way this is solved is like with a like um, like the prefix sums essentially, where essentially like you just store a difference, and then whenever you hit the same difference, then you should know that like I don't know if you've ever done problems like that, like subarray sum
Prefix
equals
sum.
k or that kind of stuff.
Yeah. Okay.
Yeah.
Okay.
So maybe you didn't know it, maybe you were unfamiliar with it, and then I think your communication was pretty good. Like you were always talking through what you were doing, but you were just like stuck a lot. And then the
Yeah.
second one, you restate the problem. So for the second one, there are a lot of important edge cases that you didn't mention until you had a complicated solution, and I kind of had to tell you that, like, hey, this is the case, right? So for the unreserved, for example, you were like, I want to have this list because what if I unreserve something that's invalid? So I would clarify all of these things. Like, can I unreserve something that's invalid? Another one would have
Hmm.
been good is, can I reserve something and I have no seats left? Like, what should happen there?
Yeah.
So you want to clarify stuff. You don't want to clarify stuff for no reason, but you want to clarify stuff if it actually matters. And I think in this case, these are the two that matters. Like, can I reserve and have no seats left? And can I unreserve things that actually aren't reserved? And then from there, that would have given you like, oh yeah, I actually don't need to keep track of anything. I can just have a heap. So basically, my approach here was after you struggled in the first one, you didn't have a lot of time. I was like, I'm gonna base the second problem based on how you did in the first one. And so I gave you like
Hmm.
I would say a pretty easy second problem. Obviously, I had a heap, but like you could see it was like 5 lines of code.
Yeah.
So even then, like you kind of figured out the solution, and I clarified everything for you, and you were still going kind of slow, and I think that's like not great because it's like it's pretty simple that you figured out all the edge cases, and you're still like, so what do I do? And I think that might be just because you're like demoralized, like from before that you're like that's totally viable to happen, like you're like, oh man, I did so bad, like I can't even think straight anymore.
Yeah.
Which is totally understandable. But yeah, that's a thing for the second one as well. Like you had a valid solution, but it took you a while. And so I'd say the second one would be like a maybe like a closer to a like a weak hire, like lean no hire or something. I think the first one was just like a bomb.
Yeah.
So what I
Definitely.
would recommend is maybe like scheduling a few more and definitely try to get more comfortable in tough situations and like yeah, just get the problem solving part quicker. Because for what it's worth, I feel like these problems are totally fair. So
Yeah. I
yeah.
agree. Yeah.
Okay, well, actually, I have another one like right now, so I will talk to you later. And yeah, if you want to book more, feel free. And if you have any other questions, you can message me and stuff.
All right. Thank you so much.
Okay, cool. See ya.